Today, today today's lecture, I will revise you the first unit, that is the bridges. And in the next lecture, we have started this transducer chapter, that is the introduction classification of transducer. So, this subject is also having a lab part also, and the lab of this was taken by the Mr. Atul Mahajan sir. In this, you are having a 5-year experiments, and then section B part. In the section B part, you are having a project, and you have to make a project, small project in each lab on the basis of these 5 experiments. So lab part is divided into the two parts, A and B, and this lab was taken by the Mr. Atul Mahajan sir. So we have started the bridges chapter with the Wheatstone Bridge, and we have discussed the history of this Wheatstone Bridge. Wheatstone Bridge was invented in the 1833 by the Samuel Hunter, the name of this person who invented the Wheatstone Bridge. And we have later named was given by this Wheatstone Bridge by the Sir Charles Wheatstone. The name of the person is the was the Sir Charles Wheatstone. In 1840s, they used the Wheatstone Bridge in many applications. So this is the history of the Wheatstone Bridge. And then how does it work? We have discussed that it having a three resistance, and it is having a three resistance, and we will find out the unknown resistance. So if I am talking about the bridges chapter, okay, so your bridges chapter is mainly consist of the two types. First one, we are having a DC bridge. Second one, we are having a AC bridge. Okay, so DC bridge means the bridges that require a DC supply, and the bridges that require the AC supply is called the AC bridge. Okay, so this one is called the DC bridge, and this one is called for the AC bridge. Further, we will categorize the DC bridge and the AC bridge. It is further into this one is called the Wheatstone bridge and Calvin bridge. These are the two types of the bridges that come under the DC category. And the AC category, we are having a number of bridges. So first of all, we are having a Maxwell bridge. Then we are having a Hay bridge. Then we are having a Shearing bridge. Okay. Then we are having a De Sauty bridge. Okay, so we are having these number of AC bridges, and these bridges are used to find out the value of the, like you can find out the value of the R, unknown resistance, with the help of bridges. We will find out the value of the inductor with the help of these bridges. We will find out the value of the capacitor. Means with the help of bridges, we will find out the value of the unknown resistance. We will find out the value of the unknown capacitance. We will find out the value of the unknown capacitance, resistance, inductor, as well as we will find out the value of the frequency also. So bridges are used to find out the values of the unknown resistance, inductance, or the capacitance, and the unknown values of the frequency. So bridges are used to find out these values, like you can find out the frequency, resistance, inductor, capacitance. So bridges divided into the two categories, DC bridge and the AC bridge, and these required DC supply. Okay, and these kind of bridges required the AC supply. Okay, so we are having a Wheatstone bridge, Calvin bridge, Maxwell, Hay, Shearing, De Sauty bridge, and we are having a Vane bridge. Okay, so this is also come under the category of the AC bridge, Maxwell, Hay, Shearing, De Sauty, and the Vane bridge. Okay, so first of all, we will starting with the Wheatstone bridge. Then I will give you the overview of the Calvin bridge, then Maxwell, Hay bridge, Shearing bridge, and De Sauty bridge, and the Vane bridge. Okay, so basically the bridges, basically starting the bridges from the Wheatstone bridge. We have started the bridges from the Wheatstone bridge, and then we are having a Calvin bridge. then a resolution occur in the field of the bridges. Then we are having a Maxwell, Hay bridge, Shearing bridge, De-Sauty bridge, and the Wien bridges. Okay, so these are the categories of the AC bridges, and they are each bridges having their different applications, different purposes. Okay, so each bridge is having its own characteristics and its own importance. Okay, so today once we have discussed all these bridges in the previous lectures, we have completed this chapter bridges. And students, you are facing problem like in the, tell me, you want a Maxwell bridge, means you are facing problem in the Maxwell bridge. So today we will discuss completely this Maxwell bridge. Okay, like I will draw the circuit diagram and I will explain you the whole Maxwell bridge here. Tell me in which bridge you are finding difficulties, like Hay bridge, Shearing bridge, De-Sauty, Wien bridge. DC bridge is clear to you or not?
Sir, DC bridge is clear, sir.
Okay, means this Wheatstone and Kelvin bridges are clear to you. Means
Yes,
first
sir.
of all, we will start with the Maxwell bridge.
Yes, sir.
Okay,
Yes, sir. Maxwell or Anderson?
Maxwell or
Anderson.
Anderson bridge. Okay, so I will explain you both like a Maxwell bridge as well as the Anderson bridge. Okay, so any other bridges like in which you are facing the problem? Tell me, students. I will explain you because I have prepared the notes of the like a chapter of transducer. Otherwise, I will today I will started the new chapter, that is the transducer chapter. So now tell me, students, other bridge you want, any other bridge you want. If you want a difficulty in that bridge, please tell me. Okay, so board is visible to everyone. I will first of all I will explain you the Maxwell bridge, then Anderson bridge. Okay. So Maxwell bridge is basically used to find out the value of the unknown inductance. Okay, we will find out the value of the inductors with the help of the Maxwell bridge. Okay, so this is the very important bridge because this bridge is the, first of all, this bridge is the AC bridge, and this bridge is used to find out the value of the unknown inductance. Okay, so this bridge is used to find out the value of the unknown inductance. So Maxwell bridge is of two type. First, we are having a generalized, okay, generalized Maxwell bridge. Okay, second one we are having a modified Maxwell bridge. Okay, second one we are having a modified Maxwell bridge. Okay, so these two type of bridges we are having: generalized Maxwell bridge and the modified Maxwell bridge. The modified Maxwell bridge is also called as the this bridge is also called as the Maxwell inductance capacitance bridge, because we will find out the value of the unknown inductance with the as compared with the capacitance. Okay, so this bridge is called the Maxwell inductance capacitance bridge. Okay, so I will share one PPT with you, and I will explain you the like a Maxwell inductance capacitance bridge. So first of all, this is the Maxwell inductance bridge. So first one is this is the AC bridge. This bridge is used to find out the value of the unknown inductance. Okay, so we are using this Maxwell bridge. Okay, so these bridges having a four arms. So this is the first arm, AB arm, that is consist of the R1 and the L1, and second arm only consists of the resistance R2, and the third arm, that is the R3 and the L3, and the fourth arm is the R4. Okay, so in this arm we are having we will find out the value of the L1 and the R1, because these values are unknown to us, and by comparing it with the R2, R4, R3, L3, we will find out the value of the L1 and the R1. So basically we will adjust the values of the different parameters like R3 and L3, and when our detector is showing the zero deflection, means our bridge is balanced, then we will find out the value of the R1 and the L1. So how to find out the value of the R1 and the L1, I will explain you here simply by drawing this diagram. Means uh, every bridge, like in the every bridge we will apply the two things. Okay, either we will apply the this one technique, z1 z4 is equal to z2 z3, or either we will find out the value of the unknown inductance or the unknown capacitance by applying this formula. Second one is the technique by divide policy. Okay, that divide policy is the a divide policy means we will divide the voltage of the, like we are having V1 is equal to V2 and V3 is equal to V4, then we will divided these two equations and we will find out the value of the unknown inductance, resistance, or the capacitance. Basically in the bridges we will apply these two techniques. First one is the Z1 Z4. This is the impedance of the opposite arm, is impedance of the opposite arm, the product of these two opposite arm, and is equal to the impedance of the multiplication of the impedance of the opposite arm. So we will do this Z1 Z4 is equal to Z2 Z3. Second, we are having a divide policy. We will divide the voltages and V1 V2 V3 V4. Then we will find out the values of the unknown inductance, capacitance, or the resistance by using this technique. So in the Maxwell bridge, we have applied the technique, that is the Z1 Z4 is equal to Z2 and the Z3. Okay, so what we have done in this Maxwell bridge, suppose this is the resistance and this is the inductance value which we have to find out. This is the R1, this is the L1. Then here we are having a resistance R3, and this one we are having a resistance R2. Okay, so here we are in the this arm we are having here we are also having a one resistance here. This resistance we will call as the R4 resistance, because like we will say this one is the R4 resistance. Okay, so this one is the R4 resistance. This is the R3, and we are having a inductor value, that inductance is known. This is the L3. Means R3 and L3 values are known to us, and we have to find out the value of R1 and L1 in this bridge. So here we are having in this center we are having a detector part that is used to show the null indication. This detector is used to show the null indication, means when this detector is showing the null indication, our bridge is balanced. Okay, so now we have to find out the value of the Z1, then Z2, then Z3, and the Z4. Then we will apply the technique Z1, Z4 is equal to Z2, Z3. Okay, so first thing is the whenever we are solving any bridge characteristic equations, first thing we will apply this formula like a Z1, Z4 is equal to Z2, Z3. Then we will find out the value of the Z1, Z2, Z3, and the Z4. Okay, so first of all, starting from the arm, this one first arm, that is the AB arm, we are having a R1 resistance. This is the R1 plus J omega L1. Mostly student confused here. What is the J omega L1? Basically, J is basically representing the iota. Okay, so whenever we are representing the inductive reactance, it is represented by the J omega L1. Okay, this is the J omega is the frequency component. What frequency we are using? Because here we have given the AC supply. So AC supply is having some frequency. So this is the J omega L1. L1 is the inductance value. So XL, this is the inductive reactance. Okay, this one is the inductive reactance. It is J omega L1. Okay, so next we are having a Z2. Z2 is B or C, resistance between the B and C. This is consist of the only resistance R2. Then Z3, that is the A and D arm. Okay, Z3 is basically R3 plus J omega L3. Okay, we are having a R3, this is the resistance, and L3 are in series again. That is the J omega L3. Z4 we are having, that is the only consist of the resistance part, that is the R4. Okay, so these are the four impedance of this bridge that we have shown. Now put these four values in this standard equation, that is the Z1, Z4 is equal to Z2, Z3, means Z1 and Z4. These are the opposite arm. So we will do the multiplication of these two impedance here, then Z2 and Z3. Okay. So when I am putting the value here in Z1, Z4 is equal to Z2, Z3. First I will write down the Z1, that is the R1 plus J omega L1. This is the Z1 into Z4, that is the R4 is equal to Z2 R2 R3 plus J omega L3. Okay, so we have put the values here. So this is the R1 R4 plus J omega L1 R4 is equal to R2 R3 plus R2 J omega L3. So we are getting this equation. Okay, so when I am comparing the real part, this is my real part and this is my also real part. Okay, when I am comparing this real part with this real part, we will find out the value of R1 is equal to R2 R3 divided by R4. So we are having this value of the resistance, unknown resistance R1 is equal to R2 R3 divided by R4. Similarly, we have to find out the value of the L1. So we will compare this imaginary part with this imaginary part. We are getting the omega L1 R4 is equal to R2 omega L3. So omega is cancelled with this one. L1 value is the L3 R2 divided by R4. So we are getting this value of the R1. We are getting this value of the L1. Okay. So this is the Maxwell bridge that is, we will find out the value of the unknown inductance or the resistance or the combination of the resistance and the inductance. We will find out the unknown value. So this is the Maxwell inductance bridge. Second one we are having, that is the Maxwell inductance capacitance bridge. That is the modification of this Maxwell bridge. Okay. So Z1, Z2, Z3, Z4, these are the impedance. We have put the value in the Z1, Z2 characteristics equation. Okay,
सर एन ही है
then okay, हाँ जी बेटा,
अरे आंसर आ गया इधर एन ही है
हाँ जी बेटा, क्या?
सर मतलब खत्म हो गया ये मैक्सवेल ब्रिज जहाँ पे
हाँ जी बेटा, we have find out the value of the R1 and the L1. Okay.
ओके सर
Next Maxwell bridge is the Maxwell inductance bridge. That I will explain you. This is the Maxwell inductance bridge. Second Maxwell bridge is having the two categories, beta. Okay. First one we are having a Maxwell bridge, Maxwell inductance bridge. That is this bridge. Okay. Second category we are having a Maxwell inductance capacitance bridge. Okay. So next I will explain you the one thing, beta. One thing I want to add here. Suppose this is the L3 is the inductor. Okay. In some bridges or in some numericals or in some diagrams, they have shown the R3 small resistance of this inductor also, because this is the inductor, and this inductor, basically this is the coil basically. Okay. So this coil is also having its own resistance also. Okay. So that its own resistance of this coil is represented by this small resistance R3, or in some like in your PPT, I have shown there this R3 is like Z3 is like this one. Okay, means we have to add this small resistance also. But in maximum books, they have neglected this small resistance. But in when you have solved the numerical part of the Maxwell bridge, examiner generally given this R3 value also. Okay, in the numerical part, they have written the value of here like this is the 3 Henry. Okay, and the value of R1 is the 10 ohm. Okay, they also given this value. Okay, so in that case, you have to consider this value, and simply you will modify this equation of this Z3 impedance simply by writing R3 small resistance. Okay, so this is the Maxwell inductance bridge. Next one is the modification of this Maxwell inductance capacitance bridge. Okay, so what is this? What is new in this Maxwell inductance capacitance bridge? We have used the unknown. We have used the capacitor also. Okay, means we will find out the value of the unknown inductance by comparing it with the capacitance value. Okay, this is the major difference between the Maxwell inductance bridge and the Maxwell inductance capacitance bridge. Okay, so I will should I explain this bridge also, students?
Yes, sir. Yes, sir.
Okay, beta. So I will explain you on this on the board how to solve this equations of this bridge, and how to find out the value of the unknown inductance and the resistance by using Maxwell inductance capacitance bridge. Okay. Generally, in the question, examiner say solve what is the Maxwell inductance capacitance bridge, and also write down the characteristics equations. Also find the equation of the unknown inductance and the resistance. Okay, so question came like this one. Okay, if you explain the Maxwell inductance capacitance bridge and also find out the value of the L1 and the R1. Okay, then first of all you have to whenever the question came, like explain in Maxwell inductance bridge, first 2-3 lines are common. This is the AC bridge. This is used to find out the value of the inductance. In this bridge, we will find out the value of the inductance by comparing it with the value of the known capacitor. Okay, then you will say that it consists of 4 arms, and each arm consists of this one, like first arm we are having a resistance and capacitor in parallel. R2 is the resistance, only resistance in the second arm. Then R3 resistance. Then we are having a LX and the RX values like this one. Okay. So first of all, I am drawing this Maxwell inductance capacitance bridge. So this is the C1 and R1. These values are known to us. Okay. And this is the value like R2. This is the value R3. We are having a R3. So like in this diagram, we are having R2, R4 basically here. This one is, they are showing like a R4. And this is the L3 and the R3, whose value we have to find out the value of the L3 and the R3. Here, this is the A, B, and C and D. And we have given the supply, AC supply, to this bridge, and here I am apply the detector part, okay, between the point B and the D. When our detector is showing the zero reading, or the no current is passing through the point B and D, then at that point our bridge is balanced. When our bridge is balanced, then we will write down the equation of balanced bridge, like this arm and this arm and this arm and this arm, these are the equal, means the impedance of the opposite arm, multiplication of impedance of the opposite arm are equal. Okay, then we will separate the real part as well as the imaginary part. Then we will find out the value of the L3 and the R3. Okay, so first of all, in this question, we will find out the value of Z1 and Z2, then Z3 and then Z4. First of all, we will find out the impedance Z1, Z2, Z3 and the Z4. So we will write down the value of the Z1. Z1 is basically we are having a capacitor and the resistance are in parallel. Okay. So Z1 impedance, in the Z1 impedance we are having a AB. C1 resistance, C1 capacitor is in parallel with the R1 resistance. So we will write down the value of the Z1 as the, that is the like we will write down R upon, that is the Z1 is the impedance of this arm AB. We will write down this resistance R1, that is in the numerator. Then in the denominator, we will write down 1 plus j omega C1 R1. Okay. This is the impedance of this R. Okay. So this is the basic concept. Basically, XC, that is the capacitance of this capacitor, and capacitive reactance, we will say like a resistance of this capacitor, that is denoted by the capacitive reactance, that is the XC basically. So XC is denoted by the 1 upon j omega C1. We will write down it in this form, 1 upon j omega C1. Okay, so these two are in parallel, C1 and R1 are in parallel. So we will write down R1 upon 1 plus j omega C1 R1. Okay. Next, we are having a Z2. Z2 is the only resistance between the point B and C, that is denoted by the R2. Then Z3. Z3, we are having a R3 in series with the L3. Okay. Z3, we are having a R3 in series with the L3. So we will write down R3 plus J omega L3. Okay, R3 plus J omega L3. This is the basically we have done in the Maxwell inductance bridge also. This is the inductive reactance basically J omega L3. Z4 we are having a like a R4 resistance. Okay, so we will write down the equation like a Z1 Z3 is equal to Z2 Z4. Then we will write down the Z1, that is the R1 upon 1 plus J omega C1 R1. This is the Z1. Then we are having a Z3, that is the R3 plus J omega L3. Then equal to Z2 Z4, that is the R2 and R4. We are having a R2 and R4. So now we will do the like a first thing we will do the cross multiplication here. Okay, we are having a R1 R3 plus R1 J omega L3. Okay, we have multiplied this R1 with this equation is equal to R2 R4 plus J omega C1 R1 R2 R4. We are having this equation. So this one is the real part, okay, and this one is the imaginary part. So we will do the like a comparison of the like we will compare the real part with the real part, and the imaginary parts is compared with the these two equations. Then we will write down like R1 is equal to, that is equal to R2 R4 upon R3. We are getting this equation R1 is equal to, that is the unknown resistance. We will find out R3, sorry, R3 is equal to R1. This R3 we will find out from this comparing the real parts. We will find out the value of the R3, that is the R2 R4 divided by R1. And similarly we will find out the value of the L3, that is equal to the C1 R2 R4. Okay, students. So this is the value of the L3. We will compare this imaginary equation with this imaginary equation. We will find out the value of the L3. So this is about the Maxwell inductance capacitance bridge. Okay. Any doubt to any student regarding this Maxwell inductance capacitance bridge? It is clear now.
सर वो Z1 वाला फिर से एक बार बता दीजिए सर, वो कैसा है?
Z1 वाला
पैरेलल है
हाँ जी हाँ
सर,
जी
वो दोनों पैरेलल है सर, कैसे किए?
So whenever the R1 and the C1 is in parallel, okay, so we have write down the Z1, that is the combined impedance of this R1 and the C1. We will represent as the R1 upon 1 plus J omega C1 and R1. This is the standard formula we are putting here. Okay, that is the when your capacitor and the resistance is in parallel combination, then you have to apply this total impedances. You will write down in this form. That is the R1 upon 1 plus J omega R1. Okay. So students see this. Tell me if you are having any doubt regarding in this bridge. I think it is clear to everyone.
Yes, sir.
Okay, beta. Next, I will explain you that is the Anderson bridge. that is also a AC bridge, and so next we are having a Anderson bridge, and this bridge is used to find out the value of the inductance also. So in this Anderson bridge, we are using the we are using the concept of star and delta connection. Okay, so I am sharing the notes. From the notes I will explain you. Just wait.